So today we're going to discuss arithmetic series. Difference between a series and a sequence is a series represents the sum of all the terms in a sequence. So the classic problem is to take and add up the consecutive numbers from 1 to a million. This would take forever, basically. But there was an individual way back, sometime in the 1800s, I believe, who came up with a quick way to do this. Super bright mathematician. What he did was he looked at this series and said, well, hey, wait a minute, what if I were to take and write this backwards? So put my 1 here, my 2 here, 3, 4, 5, 6, etc., and then counting backwards, I have a million here. One more. I have 9,900 or 900,999, 900,900, 998, 999,997 here. And he looked at those and he said, hey, check this out. I've got 1,000,001 here. A 1,000,001 here. And all the way up, one, two, three, four, five. Like so. So he said to himself, well, hey, I've got all these 1,000,001s I'm adding up. Well, how many 1,000,001s am I adding? I actually have 1,000,000 of them. Except if I add up both these series, I'm twice as big as I should be. So if I were to take and divide that by 2, I'd have my sum. And then he looked at it and said, well, let's identify those pieces. Well, the million just represents the number of terms n in my sequence. The 1,000,001 represents my first term plus my last term, and that stays consistent all the way through. And what he found was he found an equation that described the sum of any arithmetic series. That equation is as follows. The sum of an arithmetic series is equal to n, which is the number of terms in the series, times the first term plus the last term. These are values once again. And I divide that by 2. Now the crazy thing about this is this idea here, this notation and all that, the individual who thought this up was a guy named Gauss. And the crazy thing about it is he did this when he was 9 years old. He was basically a child prodigy in mathematics and physics, and kind of like a Beethoven or a Mozart or what have you. So anyways, here's another formula we've got to know and be able to apply. So let's start applying. I want to find the sum of the first 40 terms of this series. Well, I know that if I want to find the sum of the 40 terms, I need n, which is the number of terms, or 40, that's the subscript. I need the first term, which is 8, and the nth term. Well, I don't have the nth term in this case, so I'm going to have to do another problem over here. I'm going to have to find the 40th term, given that it's arithmetic. My first term is 8. My common difference is -3, and I have 40 terms. So what I now have is 8 plus -3 times 39 And that's going to get me the following, negative 109. So now I have my nth term, or my 40th term in this case. So I put negative 109 here, divide that by 2, and I have my sum, which is 40 times negative 101 over 2, or negative 2020. Next, we want to find the sum of this series. So in this case, we actually have the beginning and the end. See if this helps. So the sum of n amount of terms, and I don't know what that is equal to, I don't have a value for n. I'm going to need the number of terms, multiplied by the first term plus the nth term, which is 95, all over 2. So again, I'm going to have to do a second problem over here and say, well, 195 is equal to the first term plus my difference, which I have is 6, times n minus 1. I've got 90 equaling 6n minus 1. Divide 90 by 6. I think we get 15 is equal to n minus 1. So the number of terms is equal to 16. I now put that 16 right here, and thus I have 16 times 100 over 2, which is 800. So in this next example, we're given the common difference. We're given the 18th term, and we're asked to find the sum of 18 terms. So I have sum of the 18 terms is equal to the number of terms, which I actually have is 18, times the first term, which I don't have, plus the nth term, or in this case, the 18th term, which is 72, all over 2. I go again to that explicit formula for arithmetic sequences and say that 72, or my nth term, is equal to the first term, which is what I'm looking for, plus the difference, times subscript, or 18 minus 1 in this case. So I take 72 and I subtract off 7 times 17, and I get that 7 times 17 from this calculation here, and I end up with the first term equaling negative 47. Pop the negative 47 into here. I end up with 18 over 2 is 9 times negative 47 plus 70, which is equal to 25. And then 9 times 25 is 220. Whoa, 225. So what we're going to do in this example is we're going to find the sum of the multiples of 3 between 1 and 2000. Well, let's find those multiples of 3 first. First multiple of 3 is obviously 3, followed by 6, followed by 9, then 12, and I keep going until I get to my last multiple of 3 in between 1 and 2000. And I believe that's going to be 1998. And it is. So in order to find this sum, I'm going to need the number of terms, which I don't have, my first term, which is 3, plus my last term, which is 1998. I'm going to need to take and put that all over 2. Again, I'm going to move over and do the following, where I have 1998 is equal to 3 plus 3 times n minus 1. 1998, subtract 3 is 1995. That's equal to 3 times n minus 1. Divide 1995 by 3. Get 665 is equal to n minus 1. Therefore, the number of terms is 666. I'm going to put 666 in for n. Do the math here. So I have 666 times 2001 over 2. That's going to end up equaling 666,333. And that ends up being the sum of 666 terms. We want to find the first 3 terms in the sequence given the first term, the last term, and the sum of all the terms. So in this case, I know A1, AN, and the sum, but I don't know the number of terms. So let's take a peek. I have the sum, 2,247, is equal to the number of terms which I don't have times the first term plus my last term all over 2. So now I'm able to find the number of terms by simply taking and multiplying by 2 on both sides of the equation. So I have 4,494 equals n times 17 plus 197. So that's 214 n is equal to 4494. So take 4494 and divide that by 214. It's going to give me 21. So that's the number of terms, but I've been asked to find the first 3 terms. Well, I know the first term is 17. Now I need the second term and the third term. In order to do that, I now need the difference, but I have the number of terms. So if I have my last term, which is 197, that's equal to the first term plus the difference times the number of terms minus 1. Keep using that formula again. Then I have 180 is equal to 20 times d. So therefore d is equal to 9. Therefore if d is equal to 9 and I add 9 to 17, I get 26 followed by 35. And there's my first 3 terms. So questions for the day, here they are. The third one's a little bit tricky, but give it a shot. We will see you tomorrow.